Okay, we're going to get started. Welcome to CS188, Artificial Intelligence. Glad to see everybody made it. If you're not here for AI, then stick around. It might be interesting. So yeah, today is the first lecture, and so we'll be doing some intros today. Before we begin, I just want to acknowledge that these slides were originally prepared by Dan Klein and Peter Abil, so big thanks to them for making the slides and for making them available. So, all right. Yeah, first half of today will be introductions. So we'll introduce ourselves, we'll introduce kind of the logistics for the course, and then we'll move into introduction of AI in the second half of the course. But yeah, so we're going to talk about lectures, discussions, all that sort of logisticy stuff, and we'll try and move through it kind of quickly just so that we don't take too much time and we get into the interesting stuff. So about me, this is me. I am a first-year postdoc and lecturer in EECS. So I do AI safety research at the Center for Human Compatible AI. And this is my first time teaching as a co-instructor, so please, as much feedback as you can give me will help me to do as good a job as possible. And there will be links to how you can provide feedback if you so choose. I did my PhD at Brown in computer science, just graduated last year. My focus was in AI and decision making, so very relevant to this course. I also have some teaching experience as a TA and a guest lecturer across a bunch of different AI courses. And one note is that I'm not a professor. Please don't call me a professor. That's a promotion that I would have to earn someday, and hopefully that will happen. But you can just call me Cam or Cameron. My name is fine. The other instructor for the course is Michael Cohen, so let him introduce himself.
Hi guys, I'm Michael. Is there any way to turn this down? I'll just hold it a little way. I am also a postdoc at the Center for Human Compatible AI, doing research with Stuart Russell. Before that, I did my PhD at Oxford, and I was associated with the Future of Humanity Institute. And my research focus is also on AI safety. So the main questions that I'm looking into with my research is under what circumstances would artificial agents face an incentive to take over the world? How can we make arbitrarily competent artificial agents that don't take over the world? And how can policymakers stop people from making such dangerous AI systems? So that is my main research focus. And maybe we'll get to talk a little bit about that at the end of the course. So one other thing I'd love to talk to any of you about is the television show Survivor. That is a favorite of mine. And like Cam, I am not a professor. You can call me Michael.
Nice. Mike still on? Okay, nice. Yeah, I wasn't sure if the Survivor bit was like a bit because of all the, okay, nice. That's really good to know. Yeah, okay, so also want to acknowledge our very talented course staff, many of whom are veterans from teaching this same class last semester. We've got 3 head TAs, Evgeny, Sid, and Xavier, and then we've got a bunch of other TAs you're all in very capable hands. They'll be helping to run this course. Yeah, wave guys, nice. Any other TAs in the audience? Okay, all the other TAs are fired. No. Okay, yeah, and then these ones as well. We might have a few more people join, so we'll see. So enrollment, we have to follow the course, the course staff policies here, the department policies. So if you're waiting to see if you're enrolled, we have to wait until those enrollment requests get approved by the department, and we can only, unfortunately, let you take the class if you're a CS major. I think data science as well, and so there's more details on the course website about that. But we'll just kind of breeze through. So things that you can attend once you're enrolled. There's the lectures. There's this thing called lectures. You're here, so good job, everyone. You've made it. It's in Wheeler 150 for those of you following along with the recording later. Come join us sometime. It's great. Yeah, it happens happens Tuesdays and Thursdays, and we have this attendance policy that says, attend lecture in person, and we will take attendance, and you will get extra credit. So if you don't go, you won't lose credit, but you won't get extra credit. So that's like the incentive for you. We'll post lecture recordings hopefully by the next day on our website, and that won't count towards attendance. So you have to the way the attendance thing is going to work is like this. You can even try it if you want. You can scan this code. There's also a link on the website. And so if you scan this code or you go to the link on the website, then that will take you to a sign-in page. You'll have to use your Berkeley sign-in email address, and hopefully that's going to work. I'm not sure. And then that'll take you to this form. There's really one question on the form. It says, first you check the box that says you'll share your email address. That's just so that we can check you off. And then underneath that, there's a little box for you to type in this code, and the lecture code for today is SP24AI. You don't need to do this today because today is optional, or it's free. You get credit for it anyway, just so that while we work out the kinks in the attendance system. But when you fill that out, hopefully some people have managed to fill it out, there will be this page that says, thank you for recording your response. And very important thing, there's this piece here that says, if you have course feedback, you can use this form to submit course feedback. So every day that you sign into the class, there will be a link to submit feedback if you have any feedback. So we're hoping to get some feedback from you guys and see how the course is going. Just check in a little bit more regularly than like the end of semester course feedback would be. And both of these forms are available on the website. So you can get the attendance form, you can get the feedback form, all that's on the website. Okay, what else can you attend? There's discussions. And so this is like, if you want to hear a bit more about the topic, we'll have the TAs doing these discussion sessions. They'll be somewhere between like an hour, maybe 90 minutes, depending on the type of discussion section. And we will try to make recordings of that as well, but no promises there. The discussion schedule, it'll start next week, I think. Yeah, and we'll have the discussion schedule available on the website. You can attend whichever ones you want, so there's no restrictions. You don't have to attend a particular one. Whatever works best for your schedule. And maybe we'll throw in some extra credit for people who attend those as well. Okay, questions on the stuff so far? It might be hard to see you, so like really wave if there's questions. Yeah?
What time are is it going to be like exam prep discussions, like scheduled time?
Yeah, we'll have announcements about when those are going to be like later, when it gets closer to exam time, but yeah, we'll have those. Okay, so, and then you can also attend office hours. You can join in person or you can join remotely. You can talk to staff about content, ask questions about assignments, do all this sort of good office hours-y stuff. And the way that this works is we'll have a queue, and so we'll try to answer questions in the order that they were received in the queue. Yeah, and office hours also start next week. Okay, and then we're also going to have these things. They're called exams. So we have to do this so that we make sure that like people are learning things. And this is your warning. So those are the times for the exams. We're going to offer it in person. And then if there's like some extenuating circumstance, this isn't like you don't feel like waking up in time or like, you know, you prefer to take the exam like when you're well rested. Like this is like, if there's really a problem, then you can let us know. You have to fill out this form, and then we'll let you take it remotely. We also offer, in case of like scheduling conflicts, we offer an alternate exam right after the final exam, or right after the midterm, right after the listed time, and that's just like, that's so that, and that one's in person only. So this is your opportunity to, I'm telling you all this now so that there's no confusion when it comes to exam time, because you've been warned these are when the exams are, and we can't offer more than this. So if you can't make these exam times, maybe this isn't the right time to take the class, but yeah, this is unfortunately the best we can do. But there will be more exam logistics closer to the exam. All right, questions about exams? Yeah? So I think they won't be. They have, I mean, because there's, yeah, we'll announce where they are later. But yeah, we have to divide people up. Okay. Yeah, so here are some things that you can access. There's resources available on this website, and from there you can kind of access everything else. So slides and notes and recordings and assignments and all that's going to be posted on the website. The website is still like under construction a little bit, but hopefully most of the details are on there. And there's a banner that says like, you can't trust this information until we take the banner down. So once the banner comes down, it's all like approved. And then we're going to have a discussion forum as well. It's Ed is our discussion forum. I still think it's weird that they called the discussion forum the name of a person, but that's what they called it. It's really hard to Google too. I tried Googling it. It's like Ed, and then you get all these results for people. Anyway, so we're using that platform. I think there's also a link on our website, and then you can ask questions there. The TAs will be there. The instructors will be there. If you have like private questions, you can ask private questions on Ed as well. Or if you feel like you just want to email the course email address, there's a course email address. Some of you have already found this, so good for you. But usually making a post on Ed is faster and easier. Also, for people who are new to Berkeley, welcome. Who's new to Berkeley here? Yeah, okay, nice, welcome. So Gradescope is how we will submit assignments. This should be familiar to the Berkeley people, and then possibly some of you who are coming in from elsewhere. But yeah, so we'll submit assignments there, and that's where it'll be graded. And speaking of grading, this is how the grading structure is going to work. The course is graded. There will be 6 projects, 10 homeworks, a midterm, and a final. The 6 projects are going to be like roughly every other week. The homeworks will be roughly every week. There'll be some breaks for like spring break and things like that. The projects go sort of like this. So they're Python programming assignments. They're auto-graded. You can work with a partner, but you should be able to, they're totally doable like just solo as well. There will be reduced credit for if you submit them late, unless you have an extension. And then for the homeworks, these will be individual, and there will be sort of 2 pieces to the homework assignments. The first piece will be auto-graded, and so the idea is you'll be able to submit as many times as you want, and then you're expected to sort of get 100% on that one, so you just keep submitting until you get 100%. And then there will be a written section, which will be sort of graded by the TAs, and that you'll submit to us. So yeah, that's how homeworks are going to work. Those will be submitted individually. You're totally free to discuss them with others, but this should be your own work. And there's no late submissions on the homeworks, and that's really just because we have to grade them. And then once we post the solutions, we can't accept new submissions after that because the answers are out there. So try and get them in on time. If you have to take an extension or it goes an extra day or something like that, that's fine. Just let us know. And then there's the midterm and the final, which I already talked about. Yeah, questions on grading? Okay, great. Yeah, so I already sort of mentioned this. If you need an extension or you need some accommodation, so first of all, we'll only take the best 9 out of your 10 homework assignments, so we'll drop your lowest 1 no matter what. And then you have 5 slip days that you can use on projects, and so what that does is, the details are not super important, but basically, we will apply them in whatever way benefits you the most. So this is like reducing the late penalty for the projects. Yeah, all the policies are on the course website. But yeah, if you need an extension, please just request one. We understand like things happen, and we're here to support you. There's also this, Berkeley has this awesome disabled students program. So this is the way that the university helps us to accommodate various things that students need to learn effectively. And so if you're facing barriers and in your learning and you need some accommodations, you should just apply to DSP. This is like the best way for us to know what those accommodations are and make sure that we're teaching you as effectively as possible. So this is a great program. We're happy that we can work with them and so some of this information could be sensitive, right? So you might worry about like submitting one of these applications, and we're going to try our best to maintain like proper privacy and access controls. So not even all the TAs can see that information. It's like a select few can see those details. So yeah, our goal is to teach you the material, and the best way for us to do that is for you to tell us how to do that. So yeah, that's the DSP program. There's also, the cheating slide, right? So, yeah, there's two versions of this slide. The nice version is the top part, and hopefully we don't have to deal with the mean version. The nice version is that we are here to help you. We want you to learn. We want you to be successful. We want things to go well for you. And so if you're ever feeling like tempted, like you just can't get everything done in time, or it's too overwhelming or whatever, before you do something that you would regret, just come and talk to us. We can make arrangements, with you. We can try and help you find a way to get everything done, or there's always a solution that is not to resort to dishonesty. Of course, like collaboration on the homeworks is okay, but you have to cite the collaborators, and you have to submit your own work. And like, basically, the simple rule is like you should never be in possession of or come into like the view of someone else's solution. Don't post solutions online. Don't share them with other people. And so if you don't do all that stuff, everything will go great, and we won't have to think about any of this stuff again. That's great. The mean version is if you do decide to be dishonest, our hands are sort of tied. Like there's no changing the policies. We have to report all instances to the Center of Student Conduct, which nobody wants. We don't want to do that. You don't want us to do that. So please don't let us have to do that. And then there's like repercussions in terms of like points and penalties and like potentially failing the class. So like if all those things sound like scary and you don't want to have to think about that, then just like come and talk to us first, and we can make sure that doesn't happen. If you're ever wondering, like, is it okay to like Google how to sort a linked list, right? And you're not sure, before you just go and do that thing, and you're wondering whether it could, whether it counts as cheating, then just like either check with us or check on the course website, and if anything's unclear, ask us for clarification first, because that's the key. Yeah. Okay. And then overall, like, this is university, it's a stressful time of our lives, and so like the philosophy in the course staff is basically like your health comes first. Health, your family, you, way more important than this course. So if you're feeling overwhelmed, just know that there are options, right? Academically, if you're feeling overwhelmed, you can ask questions. You can, come to office hours, set up a meeting with staff. We can work with you, make a plan to help you succeed. And if there's other like non-academic stuff, like family stuff, or if there's like just emotional distress or whatever, Berkeley offers this counseling and psychological services department, CAPS, and they have a bunch of resources there that you can find. And then there's also the University Health Services has some additional resources. But yeah, mental health is super important, and yeah, it's not worth compromising that for the sake of like, we don't want you to have to like, pull all-nighters like 6 days in a row just to make one of these projects happen. Like, that's not the goal of the class. The goal of the class is to teach you while maintaining like, safety and mental health and all those good things. Okay, so questions on logistics before we move on? Okay, and if questions come up later, you know how to reach us. So with that, let's get to the second half, which is going to be introducing AI. What is AI? What can AI do? What is this course? Hopefully by the end of this lecture, you will have slightly less vague answers to those questions, and hopefully by the end of the course, you will have really solid answers to all three of those things. So yeah, before we get into what is AI, it's important to acknowledge that AI is kind of everywhere now. It's having real world impact. It's capturing the hearts and minds of a generation. It's hard to avoid. Has anyone heard of AI? Yeah, right. So who's played with this Chat GPT? Yeah. Or any of the other ones like Bard or Llama or Mistral or Claude or Grok or can't even think, there's probably even more, right? Yeah, they're crazy. Like you can get them to write emails for you, you can get them to download code for you, but not for this class. You can, yeah, like very interesting how far that technology has come in such a short time. And not just text, like there's also images. Like you can type text into one of these prompts and you can generate these images. Folks, have you like done this? Have you tried this? Who's tried that? And who's tried just the text version of ChatGPT or one of those other ones? Yeah, what are you guys using them for? Yeah. To write emails? Cover letter? Write code? Who else? Yeah? Getting free assets. So like generating images? Yeah, I sometimes do that for like slideshow presentations. Not this one. Yeah, who else? Yeah, just having fun with it, having a conversation, seeing what it will do. Yeah. Nice, yeah, translation. Yeah, the translation's pretty good now. Trying to break it. How are you trying to break it? Seeing if you can get it to say stuff it's not supposed to. Yeah, there's pretty like stringent like security on there now, but you can totally still break it. And yeah, some colleagues of mine are like trying to figure out what are all these jailbreaks. Yeah, who else? What are folks using this for? Do you feel like it's like really useful now, or do you feel like it's like, it's kind of useful? Who thinks it's really useful? Who can't live without it? Okay, just checking. Who thinks it's like only kind of useful? It's getting there. Mm-hmm. And who thinks it's just not useful yet? It's a waste of time. Okay. Anyone else think it's not useful? Okay, a couple people. So yeah, I mean, like so this is like one of the big things about this that I think is so interesting is that like these technologies in some sense didn't exist 10 years ago, but you know, in a shorter term sense, they did exist, but they weren't available to the public, and now they're just like everywhere. Like they've been released into the wild, come what may. One of the consequences of this is that it's having an impact on the economy. So I mean, there's lots of ways to measure this, but they're sort of estimating that like $500 billion of the global economy is AI right now. And that it's only projecting, I mean, like they always project it's going to go up, right? Because that's good to project. But only projected to go up. You heard it here. And then this is having an impact on politics too, right? Because now all the governments are trying to figure out, like, how do we regulate these systems? What should we be regulating? What should we just let the market decide? And so you see, like, the heads of all these AI companies meeting with the heads of our government and with the heads of other countries' governments and various prime ministers. And like these companies have a lot of power in the world now. They have a lot of political power. And so that's definitely some real world impact of these systems. It's also having an impact on law because we're trying to wrangle with like what's the legality of these systems, like when they are trained on these big data sets, and these data sets just come from the internet. And some of the internet is copyrighted, what happens, right? And so there was recently a ruling last summer that says, AI-generated art lacks copyright protection, and we're still trying to figure out like how do we handle these kind of things legally? There's the labor angle. There's always the jobs angle, right? So the AIs are going to come and take all our jobs, right? And so there's some articles that say, you know, watch out for the AI coming for your jobs. And then there's other articles that are like, actually, we should be optimistic. They're not coming for all the jobs. Maybe they're creating jobs too. And then there's articles that are like, yeah, but what jobs are they creating globally? Like, are these the jobs that we want them to create? Or do we want the other jobs that they took? Like, so there's lots of these sort of questions swirling around as well. Meanwhile, it's having an impact on science. So this is the AlphaFold discovery, which was sort of a breakthrough in the protein folding problem a couple years ago. And DeepMind won this big prize for basically, you take a sequence of amino acids and then you figure out how it turns into like a 3D object, like a 3D protein object. And this has been like a long-standing problem in drug discovery and the life sciences more broadly. So huge progress in the sciences, and not just in discovery, but also in control. So this is a project also by DeepMind where they're training an AI to control nuclear fusion reactions. So yeah, lots of cool applications in the sciences. And in education, then there's all these questions about, you know, why ChatGPT should be banned, and why ChatGPT shouldn't be banned, and like whether it's helping students or harming students, or, you know, it's making us smarter or making us dumber. So there's all these different real world impacts. And I'm curious, like, does anyone else, is there something that I missed that folks think, you know, is important to point out? Like, what are some of the other impacts it's having on people's lives? Yeah. Yeah, military. Yeah, how is it a military impact? Yeah, it could be weaponized. That would be very unfortunate. Yeah, how else?
Recently on Twitter, Nicki Minaj used AI-generated art for promote her new album, and everyone was like, "Why does your hand have 16 little?"
I didn't know that. So Nicki Minaj, for folks that didn't hear, used AI-generated art to promote her new album, and yeah, so it didn't look right. And then people are wondering, why are you not using artists? Why are you using this thing, right? Who else thinks of public impacts, real world impacts? Yeah. Entertainment industry, right? Yeah. So what happened last year was like all these sort of actors' strikes and writers' strikes, trying to control how actors and writers would get paid in the coming AI era, when you can just pay an AI to do all that stuff, or not pay an AI to do all that stuff instead. So yeah. What else? Yep. Could be, yeah, spreading misinformation. And this one kind of stumped me for a little while, because I thought, you know, really it's the platforms that you're disseminating the information to that would be sort of spreading the misinformation. And it's, you know, these sort of technologies are just like benign technologies. But one way to think about it for folks who haven't heard of this angle before is like, these technologies are trained on the whole internet. Who's read the whole internet before? For nobody, right? So if you haven't read the whole internet, you might not realize, but there's some pretty dark corners of the internet, and there's some pretty like questionable content on the internet. And if you're training an AI system on the whole internet, you're pulling the information out of these dark corners and you're making it accessible to everybody else. And that is a form of spreading information that isn't the same thing as a platform spreading it like on Twitter or Facebook or whatever. But that is still a possible source of misinformation spread. So yeah, that's very, very important. Yeah.
On the topic of misinformation, did you hear about the lawyers who used it and got their licenses revoked?
Yeah, there are lawyers trying to use this and not necessarily realizing that it sometimes is wrong and makes stuff up. Yeah, what else? Mm-hmm.
Research, I don't know if this is, I read this recently, like ChatGPT is making up sources.
Yeah.
I think, you touched on that?
Yep. Yeah, but people are using it for research too. I mean, I'm using it for some of my research. You know, it's helpful to survey a field that you don't know that well. Sometimes you have to go and check, make sure all those facts are real facts. But yeah, no, it has. So across like pretty much every industry, it's starting to have an effect. And there's more that we could obviously go into, but yeah, just something to keep in the back of your heads. So it's having an impact, but what is it? What is AI? Well, there's science fiction has a take on this. Is it these guys? Is this AI? Is it him? Is it this thing? Who knows that one? That's my favorite one. That's the one from Interstellar. That's Case. Yeah, one of the best like depictions of a benevolent AI system that looks sinister. There's this one, the operating system Samantha from Her. There's Ava from Ex Machina. And then we kind of get darker and darker, right? There's HAL 9000 from 2001, and then there's the Terminator T800 from the Terminator movies. Yeah, kind of a range here, right? Sort of good guys, bad guys. And also a range of generalization and specialization, right? So you have these sort of Star Wars droids, they can kind of do most of the things. And then you have Wall-E, who's really just designed to do like the garbage cleanup. But of course, like the movie wouldn't be interesting if that was all he ever did. So then he kind of generalizes towards the end of the movie. But yeah, so how can we design systems that do this and kind of the nice aspects of AI stuff? Maybe, I don't know, maybe Her is an example of that as well. And then avoid kind of some of this stuff where it's more sinister. How do we do that? Well, what kind of AI should we build? Should we make machines that think like people? This is kind of like the classical cognitive science, neuroscience style approach, making machines that think like people. There's a lot to be said for this approach. You know, but the thing is, we don't always know how people think. We just know, you know, we can kind of observe what they're doing. So maybe it's better if we make machines that act like people, right? So if they act like people, who cares what they're thinking like, right? And this is kind of a very old definition. It dates back to like Alan Turing. The Turing test is like a classic example of this. Like if a machine acts like a person and it's indistinguishable in terms of behavior from a person, then maybe that's the mark of intelligence. Yeah, so any problems with this? I can think of two problems. One is if you have a machine that's trying to pretend to be a human or trying to act like a person to a certain extent, like it's going to have to do things that humans do that might not be desirable, like getting wrong answers to math questions and having a favorite color. Humans do this all the time. We don't necessarily need our machines to have favorite colors, right? But they're going to have to if they're pretending to be like people, right? So maybe this isn't quite, and plus so the other thing is we have humans already, right? We have like 8 billion of them. So do we really need to like design systems that can act like us and be what we are? We have enough of those, right? So what about thinking rationally? This is like the classic Aristotle version of intelligence. It's like, you know, have the right thought process. It should lead you to the right conclusions. Yeah, so this is kind of a nice idea, but it kind of doesn't quite get you all the way there, because you can think forever, and if you don't actually do something with all that thinking, it kind of doesn't really mean that you've demonstrated being intelligent. So maybe there's this fourth quadrant. Maybe we should be acting rationally, right? Maybe this is the key to all of it. This course will sort of take the stance that is the way to go about it, but there's reasons to be drawing on some of these other quadrants as well, which is why they're here. But in terms of rational decisions, rational actions, we'll be using that term really specifically. What we mean by rational is that we are maximally achieving predefined goals. And goals are expressed in terms of utility. Specifically, they're expressed in terms of expected utility, because the world is uncertain, and we just want to be maximizing our utility in expectation. Now, there's problems with that as well, but that's going to be the starting point for most of the stuff in this course. And being rational means acting to maximize expected utility. It doesn't really matter how you're thinking as long as your actions correspond to whatever brings about the biggest expected utility. So that will be mostly the stance that we'll take in this course. And you could make the claim that a better title for the course would be actually computational rationality. But we'll teach you how to build learning rational agents that act in the world. Even if that world is a simulated world, you'll still be acting, making decisions and acting. Yeah, so that's the stance for this course, but I just also want to bring up a couple of other perspectives on intelligence, because lots of people have thought, what does it mean to be intelligent since a long time? And they all have kind of interesting and important viewpoints. So there's this classic skills-based perspective that just says, intelligence is a collection of skills. If you can't do X, then it's not intelligent. The system is only intelligent if it can do X, and you can replace X with your favorite task. Maybe your favorite task is to play chess, or maybe your task is to learn from experience. Yeah, other things that people think might go into this list. What would constitute intelligence? If you could do this thing, and even if you could just only do this one thing, then you'd have to be intelligent. Does this definition not resonate with people? Can you think of better ones? Okay, well, we'll get into some other perspectives soon. Maybe using words properly? This is sort of like the Chat GPT version of it, right? Maybe that's a little bit better. Yeah. Invent something new. Okay. Yeah, I like that one. Okay, nice. Yep. Yeah, nice. Solve a problem efficiently. Learn from past mistakes. Yeah, so the next one on my list is making mistakes. And then maybe not making mistakes is also an important one. We should have it probably do both of those. Yeah, what else? Yeah. Critically think. Yeah, what does it mean to critically think? Okay, using knowledge to come up with new conclusions to a question. How about folks in this section? Any other ideas? What would constitute intelligence? Making a judgment. Like a legal judgment? Yeah. Okay. Yeah. So deciding whether something is good or bad, so moral judgments maybe. Okay. Yeah. Asking questions and then answering those questions? Yeah. Yeah, okay, nice. Dealing with new situations it hasn't encountered. Who else? Yep. Pattern recognition. And then you? Okay, nice. That's kind of a pattern that we're recognizing too, right? Who else? Anything else? Make predictions? Make plans? Is pattern recognition intelligence? Okay, now we're getting some contention, right? So what counts as intelligence and what doesn't count as intelligence? Can you do this? So one problem that I have with this definition is this potentially it could give you a list of things that are necessary for intelligence, but it doesn't necessarily mean that those things are sufficient for intelligence. It might not be enough. Even if you could do all these things, you might not be intelligent. And if you couldn't do one of these things, we would say that you're not intelligent. But that's also kind of a problem for me, because some might argue that not all of these things are necessary to be intelligent, right? So there's this famous essay by Rodney Brooks called "Elephants Don't Play Chess," where he argued, among other things, that you don't need to play chess to be an intelligent creature. And so that kind of brings us into another perspective on intelligence, and this is the one that Rodney Brooks would have argued for, which is the embodiment perspective. It says that you need to have a body, you need to be situated in the world, you need to exist in relationship to an environment in order to be intelligent, and that you can't really get proper intelligence unless you have this situated, embodied cognitive capability. And so he went off and he founded iRobot, and they developed the Roomba vacuum cleaner. Anyone have one of these things in your house? Yeah, a lot of people, yeah. My parents have one of these. So they're cool. Like they map your house and they figure out how they need to go around the chairs and the walls and stuff, and then they figure out where the dirt is, and then they vacuum it up. It's like this is like a great example of the sort of embodied perspective, which essentially it says start with a ground ground up hierarchy. You want to start with like the fact that there is a body, there is this embodied conscious, or not conscious, cognitive capability in the robot or in the agent. And then from there, you just build up this hierarchy of increasingly complicated behaviors until you can do useful things, and vacuuming a house is one useful thing. So that was partly why he founded this company. Other perspectives on intelligence, I think one of my favorites is this psychrometrics perspective. This is advocated by Francois Chollet, among other people. Essentially, the idea is, well, if we want to measure intelligence, why don't we measure intelligence like we try to measure intelligence in other creatures like humans? Like we could subject these AI systems to an IQ test, give them these sort of pictures and make them sort of complete these tasks. And if we do that and we subject them to sort of a wide variety of tasks, right? A broad range of tasks, including tasks that were not previously known to the ability-enabled system or to the designers, right? Because if you just measure how well this thing does and the designers know what the tests are, you can design a system that solves every test, and then it might not actually be the system's intelligence that you're measuring, it might be the designer's intelligence that you're measuring. So that would be kind of a problem. So Chollet's idea is, no, we have to make sure that these are tests that the designers can't know about, and that there's a broad variety of them, and they're measuring abilities, not skills. So abilities sort of induce skill learning. Someone mentioned efficiency of learning skills, right? So learning efficiency is key here. But also this idea of like a broad range. It's not enough to just be good at one thing. Another important perspective on intelligence is sort of the safety angle. So Berkeley's own Stuart Russell has been advocating for this idea of human compatibility, human compatible AI. And so the center where Michael and I work is focused on this kind of concern. And what Stuart would argue is it's not enough to maximize expected utility, you have to maximize expected human utility. And it's not enough to just maximize it by telling the AI what the reward function is or what the utility function is. You have to make sure that the AI is initially uncertain about what that utility function is, and it's going to learn it over time and never be too sure that it has it right. And then in order to learn those preferences, the information that it gets is by watching human behavior. So this is the ultimate source of truth about what humans want, is just watching what they do. And there are some nice properties about systems that you design this way, in that they let you shut them off, right? So if you have a robot and you say, please fetch me the coffee, and the robot thinks it's going to go and do that some potentially dangerous way, maybe you say, as fast as possible, I really need my coffee, it's the morning. The robot might go off and do that in an unsafe way, and so you might say, okay, no problem, I'll just shut the robot off, right? Well, if the robot's goal is to maximize expected utility, and it knows that its utility is, it knows erroneously or not that its expected utility comes from fetching the coffee, shutting it off is going to prevent it from attaining that expected utility. So it's actually going to have a disincentive to letting you shut it off. So this is sort of one way that you could go about trying to fix that problem, because the robot, by being shut off, will learn something more about what it was that you really wanted, and it will be less misinformed about what it thought that you wanted. And so it gets this sort of nice teaching behavior, and it's conservative under uncertainty, and a lot of other nice properties. So there's more to say on this perspective, but it's an important perspective that I want to bring up. But I think the most important aspect for me is just this idea of generality. So there's this really nice quote by Robert Heinlein. A human being should be able to change a diaper, plan an invasion, butcher a hog, con a ship, design a building, write a sonnet, balance accounts, build a wall, set a bone, comfort the dying, take orders, give orders, cooperate, act alone, solve equations, analyze a new problem, pitch manure, program a computer, cook a tasty meal, fight efficiently, die gallantly. Specialization is for insects. Whether you agree with that or not, this is kind of an interesting perspective on what it would mean to be a human being, or what it would mean to be an intelligent creature. And many of these things are things that we listed among the tasks that would constitute intelligence. But doing all of these things, it would be pretty hard to deny that something is intelligent. What about the brain? We all have them, most of us. So human minds are very good at making rational decisions, sometimes. They're not perfect though, right? Like, who here has ever done something that they knew they would later regret? Yeah. Why would we do that if we were rational creatures? So that's one potential downside of having a biological brain. Brains are also not as modular as software. It's hard to sort of isolate the pieces of a brain that do the various things that brains do. We kind of know that like the front, the cortex is like where we do most of our like rational thinking, but of course we have this like, you know, lower like lizardy brain that's more responsible for the things that keep us alive and the innate drives that we have. So part of what's happening when we go against what we know our better judgment would say is a bad idea is like we're tapping into these other, you know, less evolved needs that our brain is sort of telling us are important. And you know, also it's important to realize that like AI might be better than brains at some tasks, right? It might just be the case that, you know, the same way we thought that biological wings were important for being able to fly, we might think that biological brains are important for being intelligent, but we later found out that you can make airplanes and they don't have biological wings, right? So we might be able to make AI systems that don't require brains. And the AI might be better in that it won't make some of the same mistakes, it won't do some of the silly things that humans do. Also, we can't build an AI that's on the scale of a brain yet. It takes like, it's like 100 trillion synapses in the human brain. And the biggest language models like ChatGPT are estimated to be like around 2 trillion. So we're like an order of like maybe 50 times off from where we need to be. In order to, if we already knew how to put all those synapses, what the architecture was in order to make a proper brain, we would still be 50 times less than the amount that we would need in order to do that. But it can, of course, still be a really good inspiration. So we can look to the brain and see, like, what are people doing? You know, how are they learning? And that can be a really nice source of inspiration. That was one of the first inspirations for how to build AI. So here's a short history of AI. In like the 1940s and 50s is when things kind of kicked off. And the first thing that happened was McCulloch and Pitts made this thing called a perceptron, which is really like a Boolean circuit model of the brain. And this is essentially the first artificial neuron. And they showed that you could do some nice things with it. And then in 1950, Alan Turing wrote this great paper on computing machinery and intelligence, and this is the paper where he introduces the Turing test, but he also introduces a bunch of other cool concepts. Arguments for why machines couldn't think, and then he sort of defeats each one of those arguments. Great introduction to the field also, if you haven't seen it before. Then there's a lot of excitement for the next 2 decades or so, logic-driven mostly. So we had early AI programs like Samuel's checkers program that could beat its creator at checkers, and then Newell and Simon's logic theorist, and Galertner's geometry engine. And these are all just sort of like people trying to cross things off the list of these, it's not intelligent unless it can do X. Well, now it can do X. And then usually what would happen is then the goalposts for what constituted intelligence would move, and you had to like do something more impressive than whatever X was. You have to come up with the next thing. And then in 1956, there was this famous Dartmouth meeting where the term artificial intelligence was coined. And this is like a great quote. Basically, they thought that they were going to solve all of this in about like 2 months, 10 people kind of thing. We propose that a 2-month, 10-man study of artificial intelligence be carried out during the summer of 1956 at Dartmouth College. The study is to proceed on the basis that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. We think that a significant advance can be made in one or more of these problems if we carefully select a group of scientists to work on it together for a summer. This was in 1956. And what were some of these tasks that they wanted to do? Use language, form abstractions, And concepts solve kinds of problems now reserved for humans and improve themselves. And like, okay, it's 2024, and some of those things are starting to happen. But at the end of that summer, they had not made as much progress as they expected to make. Yeah, things continued. In 1969, Minsky and Papert came out with this paper that says, hey, those perceptrons from earlier, those things, they can't learn the XOR function, like the parity of a bit string. That's saying like how many zeros are in this bit string, how many ones. Is it odd or even? They can't learn that really simple function. So maybe we should stop using these like artificial neural things like perceptrons. We started to work on these knowledge-based reasoning approaches in the 70s and the 80s, and early development of these was like going really well. People would type in facts to these knowledge-based systems, and they'd say like all all cats are animals. This cat is an animal. Shoot, I messed it up. you type in facts, and then you would have it like all squares are shapes. All triangles are shapes. Is a square a triangle? And yeah, is a triangle a square? And then it would say, not necessarily, and we'd all clap and we'd say, yeah, that's correct. And so that worked really well, and there was this big boom, and like all these expert knowledge-driven systems were sort of taking off. And then we sort of realized that there's sometimes that these sort of facts and these true, false, like binaries about the world aren't going to get us all the way there. Like, imagine that there is someone who wins a race, but we later find out that they won the race because they were on performance-enhancing substances, right? So did they still win? Sort of now it's a gray area, right? And how do you encode that into a knowledge-based system that only operates on these Boolean quantities? Well, that's where they kind of have a problem, which is like, if you get an inconsistency in one of these knowledge systems, you suddenly can't make any claims anymore. Like it can prove anything is true, even though not necessarily anything is always true. So after there was this boom, then there was this bust, and we had what was like called an AI winter. Then in the 1990s and 2010s, or 2000s up to 2010, there was sort of a resurgence. We wanted to try and deal with these gray areas. We wanted to deal with uncertainties and probabilities and fuzziness. And so there was this resurgence on probability, a focus on uncertainty. Also, this is kind of the first time that agents really became like a term of art, and building systems that could learn and interact and be like making decisions in the world. That was kind of this concept of the agent being central to intelligence sort of emerged around this time. And we had what was called kind of an AI spring, potentially, tentatively. And some successes also. So in 1992, there was this neural network called TD Gammon, which could achieve human level play, like human expert level play at backgammon. And then in 97, Deep Blue defeated Kasparov at chess. And then in 2002, that's when the Roomba that I showed earlier was invented. So this is like the first instance of embodied AI really sort of taking off in a commercial way. And then continuing on from there, in the 2010s, this is sort of like the big data. This is like the smartphone era. So now we have all these smartphones, everywhere, and so we're recording things, and we're texting each other, and we're always online, and so all this data is getting generated all the time. And so then all these companies were like, well, maybe we can use that data for business. And so Apple releases Siri in 2011, and then in 2012, the first neural network wins at this image recognition competition, ImageNet. AlexNet was the winning neural network. And this is the first time that neural networks could kind of compete. And this was part of the GPU revolution. So like now GPUs are commercially available, and so now you can make these bigger neural networks that can do bigger and better things. And so that kicks off the whole era of deep learning. So in 2015, DeepMind achieves human-level control in Atari games. And this is cool because they had one algorithm that could look at a bunch of different Atari games, and it would see the pixels on the screen, and it would make joystick movements in simulation, but essentially solving the human part of the game playing experience. And they achieved a human level across all these different games with the same algorithm. So this is finally, we're getting closer to this idea of general purpose behavior. And then the next year, their AlphaGo system defeated LEC et al. At Go, which was like at least a decade before anyone expected Go was going to be solved. And then in the same year, Google Translate migrates to neural networks, because now neural networks and GPUs and even TPUs are getting to that point where it starts to be useful on like a Google scale. And then since 2017, we have basically been scaling that up, and we've been working towards these large language models, and now called foundation models. So in 2017, Google invents the transformer architecture, which is like the thing that underpins all of these chatbots. And then in 2017 also, there was a big poker breakthrough. So DeepStack and Libratus sort of simultaneously, two different algorithms, defeated humans at poker. And then 2018 to 2020, AlphaFold that we already talked about predicts the protein folding structure. And then 21 to 22, that's when these sort of modern image generation from text things sort of emerged. And then 2022, end of 22 is when OpenAI released ChatGPT. And since then, every other company has released their own version of a chatbot, right? Every other tech company in existence either goes out of business or releases a chatbot by the end of the year. So that's your sort of whirlwind tour of the field and how these different perspectives on AI have kind of interweaved with each other, and we've gotten to where we are now. So where are we now? What can AI do? Here's a list of things. We can do this as sort of like a quiz, or we can just maybe a show of hands is all we need to do. Like, what can AI do on this list? Can AI win against any human at chess? If you think yes, put your hand in the air. Yes, yeah, we can. We've been able to do that for at least like 2 decades now, I think. How about win against the best humans at Go? Okay. Yeah. So right, yeah. So there was I just talked about it, the AlphaGo result, which at the end of this match, Seidel said, "This is the last time a human will defeat an AI at Go." But actually, there was a plot twist, which is that a human did beat one of those machines at Go, and it was a team of researchers, including some Berkeley people, that did this, and they basically exploited some of the intricacies of these algorithms and learned to essentially encircle the pieces in a clever way, so that the machine wouldn't see it coming because it wasn't in the training data. So yeah, kind of a nice plot twist there. But we can win against the best humans. What about playing a decent game of table tennis? A couple people think maybe we can. I guess it depends what you mean by decent, but in 2022, Google made this robot that could make 340 consecutive hits. I looked at the video. Most of the hits were like kind of easy hits, so I'm not sure if it can do like spikes and all these like crazy movements, but like we kind of can do this a little bit. Okay, what's the next one? Unload a dishwasher in any home. Who has a personal robot who can do this for them? Okay, yeah, not yet. I think I'm one slide ahead of you guys. Okay, yeah. So you can't do that yet. What about, drive safely on the highway? I'm going to say yes, because there's this article that says California just said that we can do that. But what about driving safely on the streets of San Francisco? No? Thumbs down? Thumbs up? I mean, like, California DMV hits brakes on cruises, blah, 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 right? Like, so, like, I actually drove in one of those things. I think it ran 2 red lights and cut off the cops once. Yeah. Yeah, so maybe not this one quite yet. Maybe someday, soon. So what about buying a week's worth of groceries online? Yeah, we can do that. What about buying a week's worth of groceries at Berkeley Bowl? In person, yeah, no, can't do that yet. And what about discovering and proving a new mathematical theorem? Yeah, okay. So this one's a little less clear. We can kind of do like some Olympiad stuff. Most of the progress there is in collaboration, but like we can sort of, yeah, we're getting there. What about surgeries, surgical operations? Any type of surgery? Some surgeries? Okay. Yeah, we can't do all the surgeries yet, but we can do some of them. I think Neuralink is able to like implant the electrodes that they have in people's, well, I don't know about people's brains, but like they have demonstrated that they have a system that can insert those electrodes into a brain, or at least a brain substitute. So we're getting closer to this, but nothing like super general yet. We're using it in collaboration though, like teleoperating machines. What about translating, whoops, keep going too far. Translating spoken Chinese into spoken English? I mean, this one's kind of wild. Even though there's a check mark there, I still kind of can't believe it. But yeah, we can do that. And in real time, which is kind of nuts. What about winning an art competition? Yeah, so maybe some folks know about this. This happened, actually. So first place in the Colorado State Fair was this picture. Guess who the author was? It was Midjourney. So someone typed in a prompt, made this thing happen. Now, they had to type the prompt in there, right? This thing didn't just invent this glorious picture. But yeah, this can happen now. What about writing an intentionally funny story? Maybe? Okay. Yeah, here's my attempt to get it to do that. Please write me a very funny and extremely short story because I wanted to fit it on the slide. Once there was a chicken who was terribly afraid of crossing roads, off to a great start. One day it mustered up all its courage, stepped onto the road, and halfway across it suddenly stopped and said, "Wait, why am I doing this again?" Yeah, I mean, that was the best that I could get it to do. That was like probably 50 attempts. So if you can find a better one, you can feel free to post it on our discussion platform. Maybe we should just have one thread for that. So maybe soon. What about constructing a building? People don't think we can do that yet? No? Yeah, this advertisement seems to agree. Although I will say that I have a friend and colleague who is working on a startup to construct parts of buildings. So sometimes the expensive step in buildings is creating the frame of a house, and the frame of a house is a bunch of pieces of wood that you nail together in a certain way. And you can scan a blueprint, figure out what the frame is going to need to be, and then you can build the frame with AI and then ship it on a pallet to the construction site. And you can actually automate some of the construction process. So not the whole thing yet, but maybe we're getting there. Yeah. So do you notice any patterns here? Like, what is easy and what is still hard? Yeah. Physical things are harder. Yeah, why do we think that would be? Yeah. Something that takes muscle? So our robots aren't strong enough? Muscle and judgment. Yeah, so it's this constant communication between the physical world and the cognitive world that seems to be the problem. Was there someone back in this area? Yeah, so I hear this bit about, we don't have the data on what it means to move about in the world. I mean, we all do it all the time. There's billions of people moving about in the world and doing intelligent things with their movements. But we don't have it in a digitized way that's easy to train these systems with yet. That's definitely a potential barrier. Other people have ideas in mind? Yeah. Yeah, subjective things for sure. Who else? Yeah, folks that haven't spoken up yet. Yeah.
So I think like we might have like ways of solving things with simulation rules,
Mhm.
like translating simulation rules.
Yeah, so if we can solve a problem in simulation, it doesn't always it doesn't always like match the performance when we try and take it to the real world. Yeah, so that could definitely be an issue. Yeah, did you have one too?
Sure. So it's really hard to create an embodied system that does a lot of these things. These are the physical stuff.
Yeah.
If a machine's going to be able to unload a dishwasher, it's going to be hard to make it play a decent game of table tennis.
Yeah, so the specialization required to do one of these physical tasks means that you can't quite be as specialized to do some of the other ones, or you're just a hopelessly complicated robot that's really hard to control. So yeah, so maybe that's part of it too. Yeah, there's other things that we could go into. In the interest of time, I think I'll just keep going here. So this course, as I mentioned before, is about designing rational agents. And so what that looks like is, and we keep saying agents. Why do we keep saying agents? We could say robots, but it might not have a physical body. So we could just be working in simulation, as we just talked about. So an agent is sort of a catch-all term. It just means something with agency. It means that it can make these decisions. And an agent is an entity that perceives and acts. A rational agent is one that acts so as to maximize expected utility. This perceiving and acting looks like this. So we have this loop. There's an agent on one side, there's an environment on the other side. The agent will perceive the environment and then take actions in the environment. And something between the sensors and the actuators, this question mark in this box, is what we would like to learn how to design in this course. So how do we make it do intelligent things in that question mark? And the characteristics of the percepts and the environment and the action space will dictate which techniques we'll use for doing that. So this course is about general techniques that we'll try to apply to a variety of problems. And it's also about learning to recognize when and how a new problem can be solved using one of these existing techniques. So we will cover a lot of techniques in this course. And we'll be using this concept of an agent, and the projects will feature sort of a simulated agent, this Pac-Man agent. And the way that that's going to work is we will be writing code for this AI system in order to accomplish various tasks. If you haven't seen Pac-Man before, this is what it looks like. You can only eat the ghosts when they're white, otherwise they kill you. And you can only turn them white if you pick up the big power pellet, and otherwise you have to eat as many of those little pellets as possible to maximize your score. So this is an agent that is maximizing its score. Yeah, I know, that crazy little juke move at the end. So hopefully we can design agents that are as intelligent and as dexterous as this Pac-Man agent. To do that, we're going to rely on a couple of different components. These are the core components that we'll be featuring in this class. There are others, but these are the ones that we'll be focusing on. The first is search and planning. So search and planning are like, how can I use my internal model of the world to find a sequence of actions that achieves a goal? You can imagine that I'm this agent in this maze environment here, and my model of the world is my map. It might not be a perfect model of the world, but hopefully it's enough to get me where I'm trying to go. The next piece is probability and inference. This says, how can I make sense of uncertainty? This is what's going to allow us to devise systems that are less brittle than the knowledge-based reasoning systems of the 70s, and hopefully avoid another AI winter because we can handle these kinds of uncertainties and vaguenesses of the world. Then there's supervised learning, which says, hey, that map that I was using to solve that maze, that model of the world, how do I get one of those? Can I learn a model of the world from data? And how would I do that? So a supervision signal is kind of like, you give an agent a practice test and you tell it all the answers. It studies, it tries to make sure that it can, reproduce the answers on the practice test. And then at some point, you're going to release it into the real world. It's going to take the real exam. And then you hope that it does just as well when it takes that real exam. Hopefully some of us can relate to this process. And then finally, reinforcement learning. This is the question of how can I learn a policy for any situation? This is like a set of reactive behaviors. So whenever I find myself in the situation where I'm right next to the lava or the fire or whatever, I know what to do, and it's walk directly away from the fire. Like, how can I develop a policy like that that maximizes utility? That's what reinforcement learning is about. Yeah, so these are the 4 core pieces of this course. There will also be some logic and some other sort of like smaller topics that we'll be mixing in. One thing that makes it challenging is that all of these pieces are, of course, interrelated. And so it will be a little bit challenging, but we'll try to sort of call out when these things are connected to each other and help you to understand like how all of this stitches together. Another thing that's important and we'll be covering is that, you know, on top of all these core components, there will be, you know, the obvious applications, and then beyond those applications, there will be the impact on sciences and technology and society that we sort of talked about today. So applications like natural language, vision, robotics, et cetera, games, and then impacts on society that we discussed at length. So if you're wondering, should I take this class? Yes. If you want to learn how to design rational agents, because that's what we're going to be doing. So CS188 is going to give you some mathematical maturity. It's going to give you a survey of non-CS fields that interact with AI, like robotics and cognitive science and economics. But mostly it's going to be focused on this idea of rational decision-making agents. If you are trying to get a job in AI, this is actually probably not the course for you, as funny as that sounds. So 188 will touch on some of the modern tools like neural networks, but 189, which is intro to machine learning, and 182, which is deep neural networks, those are going to be much more useful for practical, like on-the-job stuff right now. And this course is more about the broad foundation of all the techniques in AI and when do you apply them and how would you build sort of like these general purpose, rational, utility maximizing systems. So by the end of this course, hopefully, if we all do our jobs right, you will be able to build and understand the math of rational learning agents. You'll be able to select and apply the right AI method for a wide range of problems. You'll be able to recognize how these methods are used in modern AI systems and be prepared to make decisions on how AI is used in society. So next lecture, Michael will return with search, and we'll kick things off in earnest. Thanks, everybody.